Let's integrate the cosine squared of 3x. To do that, we're going to need a power reduction formula. And this power reduction formula is going to get me down to the power 1 so I can take the integral. I'm going to replace what I've got inside there. Notice that my power reduction formula acts on theta. In this case, theta is equal to a 3x. So here's what my integrand looks like. It's going to be that fraction over 2. In the numerator, I've got 1 plus cosine of 2 times my angle. So that's going to be cosine of 2 times 3x. And then, of course, I still have that dx out on the end. I can start to clean this integrand up, so I'm ready to take the integral. I'm going to split this fraction into 2 fractions, both with that 2 in the denominator. So I've got a 1/2 plus, that second numerator is going to be a cosine of 6x divided by 2, and this is all dx. Next, let's go ahead and separate this into individual integrals. You could also integrate this term by term, but I'm going to think of it this way. I've got the integral of 1/2 dx plus the integral of cosine 6x all divided by 2, and then a dx. Taking our integrals, that 1/2 is a constant multiplier. So I'm going to take the 1/2 out in front, and I'm really taking the integral of dx. The antiderivative of dx is an x. In the second integral, I've got this divided by 2. If I put a 1 here, I can think of this 1 divided by 2 as a constant multiplier 1/2. I'm going to pull that out in front, and we're going to find the antiderivative of the cosine of 6x. The antiderivative of cosine is sine, so I get the sine of 6x, but with that constant multiplier of 6, I get a denominator of 6. You could check this by doing a u substitution. That's where that divided by 6 comes from. I'm not going to forget my plus c, and I'm just about there to my answer for this one. We end up with 1/2 x plus, that numerator is the sine of 6x, all divided by 12, plus ac. Now for the next example, what would we do if we had a 4th power? So what would we do with a cosine to the 4th power of, say, 5x dx? Take a look at this next video and I'll show you how. You've got this. Thanks so much for watching.